So in the last video, again, these videos are for October 16th and October 17th. In the last video, I left it as talking about the angle of elevation from a horizontal moving up. That's our angle of elevation. For our angle of depression from the horizontal moving down would be our angle of depression. So let's see how we could apply that in this context. So for example here, we have a top of the tower, angle of depression to a stake in the ground is 72 degrees. And the top of the tower is 80 feet above the ground. We want to figure out how far is the stake from the foot of the tower. Now notice here we have an angle of depression, so we're going to have to apply this concept to actually solve the problem. I'm going to go ahead and draw a tower, and here's my stake in the ground. Now here's what's happening. So we're standing up here. This is where we're standing. We're looking down at the stake, and we know that the angle of depression is 72 degrees. Now, what a lot of students did is said, well, I know this is 80 feet, and that's true. The tower is 80 foot tall, so we know that's 80 feet. And a lot of students said, well, this is going to be 72 degrees, this angle here, because that's our angle of depression. And I'm looking down at the stake. And we're trying to figure out how far is the stake from the foot of the tower. This is the foot of the tower to the stake, so this would be our x. We're solving for x there. Now, we need to refer back to the definition. A lot of students did this, and in fact, when I first looked at this problem, that's how I did it. But it's not using the definition correctly. If we look at the definition for an angle of depression, we have to have a horizontal and then go down to the line of sight. Well, here, we don't have a horizontal here. We just did down and assume that would be our angle of depression. But if we consider a horizontal here, if I'm standing at the top of the tower, my horizontal is looking straight out. So if you think about it, this would be my horizontal in this case. Because if I stand at the top of the tower and look straight out, that would be my horizontal. So if we think about what's happening here, we have a horizontal, and then to look down to the object below, this is my line of sight, then this actually is our 72 degrees. This is not 72 degrees, okay? It's a common misconception of what the angle of depression is. In this case, we have to have our horizontal first, then we have our line of sight. That's going to create our angle of depression of 72 degrees. If you pause, rewind, ask questions, please. It can be a little tricky at first, but as we get more practice, I think it will come into, I think it will make more sense. And then we could really have two different triangles. The way I saw it is I created a triangle here. This would be a 90-degree angle. If this is 80 feet, the tower's height is 80 feet, then essentially this is going to be the exact same because we've created a rectangle. So this would be 80 feet as well. And if we're solving for x here, x is here, but because we created a rectangle, x would also be here. That's going to be the exact same length. So what's happening here, again, angle of depression is 72 degrees. Our tower is 80 feet. But we know that this would also be 80 feet. X is here, but that would also be x as well. That's going to be the exact same length. And so now we have a triangle. We have an angle in relation to this angle, the 80 feet. If we look at 72 degrees and the 80 feet is our opposite side. If we look at x in relation to the angle, x is our adjacent side. And so we're using SOHCAHTOA again, because we have a right triangle. We know that we can use SOHCAHTOA. If I'm looking at opposite and adjacent, I'm looking here. Sine is opposite of hypotenuse, so that won't work. Cosine is adjacent over hypotenuse, so that won't work. But tangent uses opposite and adjacent. So what we can say is tangent of 72 degrees equals opposite, which is 80, over x. And now we can solve similarly to what we did here. We're dividing by x, so let's get that out of our denominator by multiplying each side by x. If I multiply this side by x, these x's would actually divide out, and we're left with 80. And then we can divide both sides by tangent of 72 degrees. And get x is equal to 80 over tangent of 72 degrees. So once we get the triangles, a lot of students were able to calculate using sine, cosine, or tangent once we got the triangle. The key thing here is being careful. If it's an angle of depression, we have to create this horizontal first. Once we create the horizontal, then we can create our angle of depression and get a solution. Again, if you need to pause, rewind, ask questions, please feel free to do so. I'd love to answer any questions that you have about this. I'm going to scoot to the back side, kind of talk about one problem here, and then let you solve. So in this problem, I'm going to let you try to set it up. Essentially what you're going to end up with, though, is that you're going to have sine of 72 degrees in some form or another. That's going to equal x over 110. And some students got to this and kind of struggled a little bit. They said they wanted to multiply by x. Well, if you think about it, what's happening here? X is being divided by 110. So if I want to remove the 110, get x alone, we can just multiply both sides by 110. Again, this 110 would divide out. And you would get x alone. Now that's not your final answer. If you actually want to, if you want to pause it, work it out, get to a final solution, go ahead and do that. But your actual final solution would be, actually, sorry. Let me erase this. I'm going to say this is the height, because it wouldn't be x per se, but the height would be this plus 8. But I'm going to let you work that out and see if you come up with that solution. Again, if you have questions, feel concerned about anything, please feel free to ask me through the Remind app, email, website, in class, tutoring, whatever. We'd love to answer your questions. We're going to continue looking at these in the future, but that's what we did on October 16th and 17th, looking at how we could use sine, cosine, tangent to solve real-world trigonometric problems.